The suspension of the all-new electric GLC represents the unmistakable DNA of every Mercedes-Benz. We call this the Mercedes-Benz driving character. It is based on ride comfort, driving safety and sovereignty, complemented by sportiness and precision. At the beginning of each development cycle, these characteristics are translated into over 130 physical parameters for vertical, lateral, and longitudinal dynamics. These form the basis for extensive calculations, simulations, and design variants before the defined target values are incorporated into the suspension components. When driving over individual obstacles, such as speed bumps, the forces that occur are absorbed both vertically by the dampers and horizontally by the tension strut bushing. The optimization of the interaction between the dampers and comfort bushing ensures the Mercedes typical comfort behavior in the GLC. In all driving situations, the all-new electric GLC offers the optimum balance between driving dynamics and ride comfort. Thanks to the known air suspension technology from the Mercedes-Benz S-Class, bumps and vibrations are almost completely absorbed for a remarkably smooth ride. The continuously adjustable damping system offers the perfect synthesis of long-distance comfort and sporty agility. Driving over road bumps on one side, such as manhole covers, poses a particular challenge for the suspension. Crosstalk to the unloaded side needs to be cancelled out. The vehicle absorbs the bump on one side. Intelligent suspension control includes a new car-to-X function that provides significantly more comfort on long speed bumps. If the system detects an upcoming elevation via the Mercedes-Benz Cloud, the electric GLC adjusts the damping electrically shortly before the obstacle, which is particularly noticeable in the rear. The basis for the damping adjustment is car-to-X information that a Mercedes-Benz vehicle traveling ahead has transmitted anonymously to the Mercedes-Benz Cloud in real time via the mobile network. Because the sensors of other cars are also used, the technology significantly extends the coverage area of the vehicle's own sensor technology. The function was solely developed by Mercedes-Benz. A patent has been applied for. The rear axle steering in the all-new electric GLC is based on electromechanical actuators that precisely control the toe angle of the rear wheels. Control is adaptive via the driving dynamics system and takes into account speed, steering wheel angle and driving program. The current steering angle is shown in the central display, so the function remains transparent to the driver. At low speeds, the rear wheels steer up to 4.5 degrees in the opposite direction to the front wheels. This reduces the turning radius by 90 centimeters to 11.2 meters. The vehicle is more maneuverable, nimble, and agile in tight corners and easier to park. At higher speeds, the rear wheels steer in the same direction as the front wheels. The resulting virtual extension of the wheelbase offers noticeable advantages: increased driving stability and safety at high speeds, fast lane changes, or sudden evasive maneuvers. This is also evident in the so-called double lane change, a test drive that is specified by pylons and simulates an obstacle suddenly appearing on the road. In this maneuver, rear axle steering can significantly improve performance by increasing stability and improving responsiveness. The all-new electric GLC combines maximum driving comfort with unprecedented agility. This has been achieved in particular through the functional refinement of the interaction between the rear axle steering and the ESP driving stability system, developed by Mercedes-Benz.